Hi everyone, welcome to my channel. My name is Sarjun. I'm a data science trainer, a lecturer, and an industry practitioner in this field, and a mentor to the youth. This is the third in the series of basic R programming concepts. So, before we start, I would like to request that you follow me on my socials: Facebook, Instagram, Twitter, YouTube. Like, share, subscribe, send me a message, and I'll get back to you as soon as possible. Thank you. So now getting on to today's segment. Okay, we're going to be looking at data types. Okay, so what we're going to be covering today is, we're going to be covering today is variable data types, operators, casting, and conversion of data types, right? You see, I have this suppress warning code here. This is basically to switch off certain warnings that will pop up unnecessarily, usually due to certain changes in the code, the operations of the code, or certain libraries have deprecated. So for me, I prefer not to kind of see those things because it kind of interrupts my teaching process. But for yourself, if you need to know your warnings and errors, you better keep it turned on and don't turn them off, right? So with that said, let's start off with variables. So variables are reserved memory that store data values, unlike other programming languages, right? Such as C, C++, Java. R does not require a command to declare the variable data type. You just have to assign the variable data type, and then it will automatically store it first in a particular data type format that it suits for it to be the optimal data type to process that data that you passed in. And then later you can change it, you can cast it, you can convert it, so on and so forth, right? The arrow plus the dash together give you the assignment operator. This we covered in the previous session, right? The same variable can also be used to store different values as mentioned, but only the latest assignment of the variable value will be retrieved. As I mentioned, it will be overwritten, right? So let's now do an example of a variable. So let's create a variable person name. So let's go and create person name and assign it with Gary, right? Remember, Gary has to be in strings. Strings as to be a string variable, so it needs to be in quotes, right? Create a variable age. So age is going to be in what we call number, a numeric value, right? 23. Then we are going to be doing create a variable called salary. So salary, right? Apologies for my typos. Salary is equals to 25751.3, and I'm going to do marital status. So marital status is equals to married, right? Okay, so I want to do some simple, I want to start off with some simple print statements first. So print person name, right? I can do a print age. I can also do print salary, and I will do print marital status. And I just need to run this. So you can see the first one is person name, which is Gary, and then is 23 is his age, salary is 25751.3, and marital status is married. Simple, right? Now, I want to create a variable name, variable person name called Gary, and then I want to reassign that name and see how that works about, right? So here I'm going to create a person name called Gary. Person name, I'm going to set it to Garry, actually not RRY, Gary, right? And then I'm going to cat, so I'm going to say first time print, you can call it a first time cat function. Let me make it more clearer. Cat function, what does it give, right? The person name variable now is, okay, I'm going to pass in the person name as the third variable. Remember, cat function, you can put in as many variables as possible, of many segments of words as possible. I can do a /n to make sure that that's the n, right? And then I'm doing a cat again. I'm going to do, before I do the cat, I want to do some changes. So now I'll do person name. This time around, I want to save it as Roger, right? Roger. This time, cat. Second time, cat function. This is the second time I'm using the cat function, right? The person name variable now is comma person name, right? When I run this, you can see the first time the cat function, the person name variable now is Gary. Second time the cat function, when he prints it out, the person name variable now is Roger. You see it has changed after this line of code because I've reassigned the value, right? So that is something you need to be careful about, right? Using multiple variable assignments in a single line operation. Obviously, I can assign multiple variables. So here, let me show you what I mean by multiple variables. I can say Gary's age comes from Roger's age, which comes from Tom's age, which comes from the value 26. So 26 will be assigned to Tom's age. Tom's age got 26 will be assigned to Roger's age, and Roger's age of 26 will be assigned to Gary's age. So now, when I do a cat here, the cat function, I want to do, I want to do Gary's age is Gary age, right? And then I do an n equals to /n, right? And then I do the same thing for cat Roger's age is, I put Roger age, and then n equals to /n, and then cat. Well, this is where you need to type. Typing, wow, not easy, but you type means type lah. Because I'm teaching, right? Type must type. Tom's age is Tom age. Tom age. Okay, so en. So I'm just being consistent lah. I don't have to do the last one, but I'm just doing it just for consistency, right? And you can see Gary's age is 26, Roger's age is 26, and Tom's age is also 26. So there is, you can see that proves that the assignment can work in a single line operation. You assign one to the other as well. Okay, how do variables react to changes when variables are assigned to each other? Okay, so this is where we are looking at how variables, when you assign a variable, when you assign a value to a variable, and then you assign this variable to another variable. So let me show you an example, right? May get a little complicated, but when I show you an example, then it will make more sense. So let's say person name here is, messages, right? Anyway, person name here is Roger, right? I want to do that first. And then I want to set a variable name, friend name. I want to assign it from person name, right? So now Roger is in the person name, and person name that has Roger will be assigned to friend name, right? So friend name will get the Roger and put into friend name. So now if I were to get this out, so cat, I'm going to do this. I'm going to do the variable person name is person name. Okay, I'm going to do a bit of shortcut here, so please bear with me. Sorry, /n must be this one. Okay, and I'm going to just copy this so I don't have to type it again, and I'm going to change this to friend name. Okay, and I'm going to run this, right? You can see that, this is supposed to be friend name. Since I copy and paste is the problem. Okay, so the variable person name is Roger, the variable friend name is also Roger, right? Now let's do something else. Let's do person name is Roger, right? And then I want to set the variable friend name to person name, right? Which is the same thing. I'm doing this, so I'll just copy this, right? And then what I want to do, I want to reassign person name, this time to Gary, right? And then I want to display this. So let me go through this again. So I want to assign person name, Roger. I want to assign this Roger from here, from here goes into friend name. And then now friend name has Roger. But now to reassign the first person name that I had assigned initially to Roger, now to Gary. And then I want to print out this. And when you see that, you can see that person name now is Gary, but the friend name is still Roger because that was assigned first. So you can see that that order of how it's assigned also makes sense, right? You need, just because you changed the previous value of person name, now it's already assigned and it's moved on. So the person name now changes. So the variables you need to follow them very carefully, right? Okay, runtime variable assignment. So runtime variable assignment is where you pass in a value in the code itself. So one way of passing in a runtime variable assignment is using this thing called the readline prompt. So let's say something like person name. Okay, then I can use this function called the read line. The prompt will be, please, let me do a capital. Oops. Please enter your name, right? And then a simple cat function with welcome person name. So when I do this, see now I have this, please enter your name. So let me put Sarge. It says welcome Sarge. Let me run this again. If I put Aaron, it says welcome Aaron, right? One important thing for you to understand when you're doing this kind of variables, it's good to understand your type of. The type of function gives you the type, what variable data type is your data type that you're looking at, right? So you can do a print, right? Type of bracket. Actually, you can do a type of itself, but it's just that print is the better way of doing it. So if I put a person name, it's this character, but it's always important to put a print or a cat function in front so that it will display it out into the display. Then it will display. If not, it will not display lah. Right? It's better to use a print function so that it really displays it out explicitly, right? It's an explicit command to print. Right. Okay, a quick practice. I will give you some time to go through this and try it out. And then we will, actually, I'll still carry on discussing this, but you should take some time, pause the video, and try this out, and then start back soon, okay? Okay, let's do this quick practice. Now, here the question is asking you to use a runtime variable assignment to assign Gary to the variable boy name. So it's just not assigning boy name to Gary. It's not like that. You need to use the runtime variable assignment, which is what we just learned here. So instead of just making it, type Gary to the variable boy name, we need to type boy name with the read line option with the prompt as, notice the prompt also has some assignment, right? Because we are assigning this to be the prompt. Please enter your name, right? So maybe you want to make it line nicer a bit, right? So something like that. This nice, right? And then I want to do a boy age. Read line. Prompt. Please enter your age. Now we want to do another runtime variable, which is the boy occupation. Again, so in the interest of time, I'm going to copy and paste, right? This will keep going on, right? If I don't, right? So please enter your occupation, right? Similarly, I'm going to do boy money, right? And similarly, it's going to be, oops, I see two arrows here. That's it, right? And then here's, please enter your cash amount. Simple, right? And then, but it doesn't end there, right? This is just taking in the inputs. I need to print them out explicitly. So I'm going to print. You can do a cat. You can do a cat to print all of them out together, right? I'm just going to use simple printing them out separately, right? You can do a cat, comma, 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 and you can print them out in one line, depending on how you want them to be printed, right? I'm just doing something simple, right? Print boy age, print boy occupation, and print boy money. Okay, and then I will run this, right? And then I'll say, please enter your name. So I'm going to put my name as I said, Gary. Age is 8 years old. Occupation is student. And the cash amount is 35. You can see that. That's what it's going to print. Gary, 8, student, and 35. Right? So it's quite simple. The second part of this quick practice requires you to assign age 24 to Mary, Maggie, and Shona. This is quite simple. So Mary, Maggie, and Shona, right? All I need to do is, once I do this, I just need to assign the age 24, and I can just print out Mary lah, just to show that it worked, right? And that is basically, sorry, I think they jumped too fast. You can see that when I do that, Mary, Maggie, and Shona, it just print Mary and it gives you the output as 24. It works, right? So, simple stuff, easy. Let's move on to data types, right? Okay, now we're going to be looking at data types. There are different data types that are stored in a programming language, right? So different programming languages call them differently, but they are in one sense or another similar, right? So we have character data types, we have numeric data types that consist of float and double, we have integer data type, which is integer without any decimals, we have logical data type, we have complex data type, and we have raw. There are different types of data structures that can be used to store the different data types. Note that these data structures and data types are interchangeably called variables, so do be careful because sometimes lists and factors and vectors also called as variables. So yeah, so you need to be able to distinguish between them. But don't worry so much. We will cover the basics here, right? So we'll be covering character data type. So a character data type is one that holds a specified character or string values in a variable. The use of single quotes or double quotes represents character data type. Usually single quotes is used for holding a specified character variable and double quotes for a string value, right? It's just a convention. Yeah, it's up to you what you want to do, how do you want to store your character data type. A numeric data type is one that may take on any value within the finite or infinite interval values, usually categorized as float or double. An integer variable is also a numeric variable, but does not have any decimal values and has the suffix L, is used to specify an integer variable. A logical data type is also referred to as a Boolean data type that can only hold two possible values, either true or false values. A complex data type is used to specify purely imaginary values, usually with the suffix I for the imaginary part. A raw data type specifies values as byte data with the char to raw and raw to char as functions that can be used to convert between raw and character variables. Okay, so let me just show some examples of a character data type. But before I go into that, I want to let you know that if you have a string value of, say, it's not a string value, a number value of 9, and you add quotes to that 9, that automatically becomes a string variable. So you need to be very careful about that. So just because when you store a value as 9 with quotes, doesn't mean that just because it's number, it's a numeric variable. If there's quotes, it's automatically treated as a string variable. So you need to be very sure about that. So usually string variables are used to store text and non-numerical variables. So let's initialize a variable called my name. So here I'm going to initialize a variable called my name. Okay, and I'm going to say this is such, right? And I'm going to do a cat. My name is, and as usual, I'm going to add my name to show you what it is, right? So you see my name is such, right? Now, I think I did this earlier in one of the segments. I'm just doing this again. So I'm going to do cat. Your name is your name, right? So in this case, because your name is not defined, the variable is not defined, you're going to have an error. So it's going to say object your name not found, right? So that's something you need to be careful about. So let's try this again. Let's do your name, but this time I want you to fill your name with a particular value. So fill in your name. So I'm going to put fill in your name, right? And then I'm going to display it. Cat, your name is your name, right? And when I run this code, you will see that your name is, so this is where you have filled in your name, right? So your name is filled in your name. So that's how this works. But one important thing is you need to know what is the data type of your variable called your name. So again, I'm going to just copy this technically. Okay, this time I'm going to put this as, I'm going to give it a reasonable value, participant, right? And then I'm going to do print type of your name. Now it's going to give me an output, which is character. So you can see the variable your name is of the type character. So that's something you need to understand, right? You need to understand that this data type of your name is actually a character data type, like what we saw earlier, right? Numerical variables are a little bit different, but in order for us to use numerical variables, we need to, in this case, for float, for the purpose of using float, we need to install this package. So I'm going to use install.packages, as I mentioned. You won't have to do too much of it, but just in case your system does not have it, just install this and then make sure that you call out the library called float, right? Because I want to show you the importance about float. Okay, so install packages, float, and I'm going to use library float. Okay, once I do this, my float function is available to me. The difference between double and float data types, right? We're going to show you what's the difference, right? Then create a variable num units purchased with 5, right? So I'm going to do num units purchased is equals to, or assign the value 5. Then create a variable sales price unit with 4.5. Okay, but I want you to use the sFloat function. So I want to use s.float. This is the sFloat function, right? And 4.5 as the parameter within it. So like this, right? And then now I'm going to type in print num units purchased. Okay, and then I want to print sales price unit, and then I'm just going to do a just something like this lah, just to show you that to segregate this and the next line. So END, sorry, I never put equal sign, and okay, and then I want to display the data type. So I want to display the data type of variable num units purchased, okay, is, remember I said type of, if you want to find a data type, you need to put in num. So here I can just call on this in IntelliSense, in a sense, right? Again, I can just copy this. I don't want to type it out. And I just paste it. Variable is sales price unit is type of, and then I remove this and I type sales price unit. Okay, and then I run this code. So it's installing my library. Remember, it takes a bit of time. You can see that 5 is a float, right? Sorry, 5 is a double, right? Because that is printed first, 5 and then 4.5. So this particular value here, the data type variable of num units purchased is double, whereas the data type of sales price unit is of float 32, right? So that's something you need to be very careful about, of why when I use as float, it's saving it as a different value, and when I save it as a double, it's saving it as a different value, right? Okay, so now let's move on to integer variable value, right? Okay, so integer variable value is quite simple. It's just an integer without any decimal point, and it's not a numeric value, it's an integer. So for integer, it's quite standard in R. You just have to add the assign this integer number with the value 16 with an L beside it, and then this is an integer value. So I can just print int num. Okay. Similarly, okay, let me go back and copy this. I don't want to copy the whole thing again. Okay, so let me paste this. Data type of variable int num. Okay, I can do a type of here, int num, to show you the same. And when I run it, you can see 16. The data type of variable int num is integer. Okay. Okay. Okay, so now we're going to be doing what happens if quotes are added to a number. Okay, I think I covered this briefly, but let me just show you the exact context, right? If now, instead of 8, now you see 8 has this quotes, right? So 8 is no longer a number. You're assigning a string of 8 to the variable x. While y, I'm assigning 5, right? And then you can see that again, I'm just going to paste this here, right? So the cat of variable x is, so I'm just replacing it, right? Type of x, and then I'm going to do the same thing for y, and the sales is also y, right? So the data type of variable y and x. So you can see when I run this, the data type of variable x is a character, while the data type of variable y is a double. This is something you need to understand, that with the quotes, it is no longer a number, right? But the 5, when it's without the quotes, R is smart enough to realize that actually, you're passing in a number, right? I'll save it as the data type double by default, unless I use the float, float option to save it as a float, right? Depending on what is the purpose, whether you want to save it as a double or float. Usually double takes up more memory space compared to float, right? Float takes up lesser memory space. So those are the reasons why they differ. Okay, similarly, there's also a difference between a number and an integer data type variable, right? So here I'm going to assign x to the value 1, and I'm going to assign y to the value 1l. So 1 here is an integer, 1l is an integer, but 1 with a string is actually not it's a string, right? So I'm going to put, this time again, actually I can just copy this because it's the same values, right? I can just use this, and I can run this. So you can see this time, the variable x is still a character, but the variable y is an integer, right? So you need to be very careful about when you use them. Logical variables, on the other hand, the use of logical variables are actually, or otherwise known as Boolean operators, are important in many situations, especially when you need for the R program to make decisions, right? If you have a target of hitting 1000, so the moment if your R program realizes that you've already hit your target, it will switch your variable that you're looking at into true, and then stop running certain commands or something like that, right? So it's how you use this Boolean function, right? So in order to do that, I need you to first create a variable called true value So true value is equals to, okay, don't use equal. See, I'm very used to using the word equal. So true value is equals to, not assigned to true, and false value is assigned to false. And then I want to know the variable. I want to print the variable true value is, so that I can show you what the true value is, right? True value, and this with /n, right? At the same time, I want to the variable false value is false value. So I'm just following through, right? And this with same thing, right? And then I want to do a separation just to show you that, right? Something like this. I want to do something like this. I want to show you this. Okay, just to show you a split. And then here I want to show you the type of as well. So let me just copy this from here so that I can do the type of. I don't have to type it again, right? But I think you must have, I mean, the data type, you have to type it. So data type of true value, right? So here is going to be true value, and then here is going to be false value and false value, right? And then when I run this, you can see that the variable true value is true, the variable false value is false, but the data type is automatically logical in both cases, right? So that's what logical variables are. Simple as that. Okay. So complex variables are a little bit slightly different, right? Let me just give me a moment. Okay, complex variables are, it's not important so much. We will not cover complex variable in detail, but it's usually complex variables contains a component I, an imaginary part. So just want to show you how that works, right? So here I'm going to create complex value equals to 3. So there's a real and there's an imaginary part, which is 6i. This is how it's determined, so, right? So you can already see that when I copy this and paste this here, and I just want to see a type. I'm not really worried about the output of what it gives me. I just want to show you that this is a complex value. If you are keen in this area, then that might be something you want to look at, right? So complex value, a data type of variable. I'm supposed to write complex value here. Complex value. Sorry, okay, copy and paste. Okay. So data type of variable complex value is complex. Okay. The last part of this we're going to be covering before we do a quick practice is we're going to look at how we can do a conversion, right? Raw variables. So what is raw variables? So the raw variable stores values as raw bytes. Okay, so let's create a raw value. I'm going to create a raw value here, char to raw, right? And I'm going to do learn with such. Okay, so learn with such is going to be my raw value that I'm converting from char to raw, and I'm going to print, right? I'm going to print the raw value. At the same time, I'm going to do a data type to show you what data type it is, right? And then I'm going to do the, just let me copy this. Okay, sorry, pasting at the wrong side. Okay, so let me just change some of these values. Raw value, okay, and then I'm going to create a value called char value, okay, and my char value is going to be a raw to char conversion, right? So I'm going to pass in the raw value. So I'm going to revert it the other way around, and I'm going to print the char value similarly, and I'm going to print the data type of the char value. Okay, I missed out a bracket here, right? Okay, let me just do the same thing. So you can see I'm creating a raw value and then I'm doing the reverse, right? Practically, just to show you how these things work. Right? We will not be using this too much unless you're interested in these data types and all that. Oops. Sorry, yeah. I think I did something wrong. Raw to char. Sorry, yeah, it's not. See, I missed out a capital. So it's raw to char with the capital T. So that makes a difference. So you can see, the initial one, this is my raw value for learn with such. Then I pass this back into the system to convert it to a char value, and it gives me back learn with such. It's something like coding, decoding kind of thing. So yeah, if you're interested in this kind of raw variables, you can use them as well. Okay, moving on to a quick practice for you to try it out. And yep, and you pause the video, try it out, and then we can discuss this as well. So try it out before this. I mean, I'll continue, but please do try it out, and then we can follow along and learn as well. Okay, so now we have to assign 5,000 to the variable num units available and assign 1,000,000.50 to the variable price per unit using function as float with 1,000,000.5 as parameters, then display both the data types. So it's quite a simple exercise. I think you must have tried this out. Not so difficult. So basically num units available, right, equals to 5,000, and then do a price per unit. So I don't have to import the library again because I already know I've already done that earlier, right? As float, and then you pass in 1, 2, 3, 4, 5, 6. I think 6.50. Right, and then I just need to print the data type. So I can do type of for num units available, and similarly print the same for price per unit. Simple. And you see I get double and float 32 as required as well. Okay, so operators. Moving on to operators. There are many types of operators in R. So arithmetic, relational, logical, assignment, and others. Okay, we'll cover a few of them here. Okay, let's try some simple arithmetic operators. So let's print 5 plus 7. So print 5 plus 7, right? Simple. You get 12 because the formula itself evaluates this plus function with 5 plus 7 in print, and then it just comes out as the total value as the output. Okay, you can also do arithmetic operators with variables, right? So let's try x is equals to 3, y is equals to 5, and z or z, whichever that you call it, is equals to 9, right? And then I can do a new variable called total value, which is assigned to x plus y plus z, right? Then I print total value, and that gives me 17 as expected, right? I can also use the negative operator to do what we call subtraction, right? So all this shouldn't seem very difficult, but if it does, please do try to follow as much as possible and try to understand them, right? So x is equals to 3, y is equals to 5, and I'm going to put a total value equals to y minus x. You can definitely x minus y as well, but you get a negative value, so just be careful about that. And then you print total. Yep, total value, right? You get 2, right? Simple. You can also do a times. Okay, similarly, I can just copy this. I can just do a simple times, right? I can do a x times y, and I get 15, right? I can also do a divide as well, right? Same thing. I'm just going to change the variable, this y divided by x, and I'll get 1.66667. Okay, so these are the basic times, divide. All these are quite Simple. Okay, this one I think might be new. This is what we call the modulus operation. So this percentage sign, twin percentage signs, gives you back the remainder of the variables. So let's try this. So example 26 divided by 6. So 26 divided by 6 will give you output of 4 and point something if it's decimal. But if not, it'll give you 2 as remainder, right? In this case. So if I now assign 26 to x and then y, I assign 6, right? What I'm going to do is I'm going to set the total, or let's not put total value. Let's call it remainder. If you notice, I am following this case where my first alphabet is always small. It's called camel case naming convention. So the first value is remainder, then the value, it's a capital V. So it uses remainder value. So remainder value, it's camel case concept. So it will just give you it's just to give you a good understanding of what the variable itself is, right? So one way to do that is so remainder value, I'm going to do x percentage sign y, and then I'm going to print my remainder value, right? And the remainder value here is 2. Simple, right? Similarly, I can also do what we call a power, or what we call an exponentiation function. So here I'm going to do the same thing, but instead of 3, I'm going to use 3 and 5. I'm going to do the exponential function with x equals to 3 and y equals to 5, and I'm going to do the exponentiation function. So x with a double star and y, and I'm going to print total value. It's 243. Okay, let's handle this quick practice question. Okay, so basically the task is to create a variable 5 and assign it with the value 5. Create a variable 5 float and assign it with the variable s.float 5.0, right? And then you want to assign the outcome of the variable 5 divided by 5 float to the variable my value, right? My value is going to be 5 divided by 5 float. Similarly, you want to do my value dBl with 5 divided by 5. And then you want to do my value float with 5 float divided by 5 float. Right? Simple. Right? Once you do this, what I'm going to do is going to print, as usual, type of my value. And I'm going to do that same print type of for my value double and my value float. And I want you to see that when I print out this, you can see that the first output, when 5 float divided by 5 float, when it's a float, when divided with a double, the double takes precedence and it becomes a double, right? Because precision, right? That's the highest level. When you divide 5 by 5, both are double variables, right? It gives you a double. Simple. When you divide a float, 5 float by 5 float, it gives you back a float. So you can see a consistency, right? So you need to understand this. Right? This is one important takeaway, right? So moving on, conversion and casting, right? Okay, now we will move on to conversion and casting. Okay, so R supports the conversion of one data to another, provided it's a valid conversion, right? And usually there are two types of conversion, right? One is implicit conversion that's done by R interpreter with intervention from the programmer. And explicit conversion, that is conversion that is user-defined and forces an expression to be of a specified data type, value. So yeah, so one is implicit, one is explicit. So let's look at an example of an implicit conversion. So implicit is, in a sense, done by the R program itself. So let's create a variable called num units purchased and set it to the value of 5. And then we do a sales price unit and set it to the value of s.float 4.5. So this is how I'm showing you what happens if there is a float and a double. What happens to the variable when you do some kind of combined computation or calculation on them, right? So we initialize a total variable, so not total variable, total price variable equals to 0, and you want to display all this variable data type. So you want to see sales price unit, print sales price unit, and then you want to print what is the sales. Let's see if I can do this. Sales price unit. Yep. This. Oops. I printed it twice. Yep. Then I do a print type. So I'm using my IntelliSense. Right. IntelliSense is just when I do a tab, it just converts it, and I do a print. This is to separate the different components. So I do a print number of units purchased. So this is where we have the print num units purchased, and then I want to do a print and to show 1, 2, 3, 4, 5, 6. I'm forgetting something. I'm forgetting the type of. Yep. And then I do a print to segregate them. Simple, right? And then I do a print total price. And then I do a print actual total price value. This one is just the string value, just to show you that it's total price, right? And then finally, I print the type of. Wow, so many type of. Yeah, this is something you need to, because I'm teaching, so I have to do this, right? Right. But you don't have to, be so detailed, but, it's good practice lah to be. Okay, so let me run this. You should get sales price unit is a float vector of 4.5. It's a float basically. Its data type is float 32. I think we already know that. Number of units purchased is 5. It's a double. Total price is 0. It's also a double. Right. Similarly now, I'm going to do the same thing, but this time my total price, I'm going to just tweak it a little bit. So what am I going to do? I'm just going to copy this to, which is a num unit purchase of 5 and sales price as float, and I'm going to do this. I'm going to change. I'll just type out. Okay. I just want to copy this print, the last part here, which is print total price, the total price and type of, and I want to see whether that changes or not. Right. So I'm going to do total price is equals to num units purchased times, let me do sales price unit times num units purchased. That's num units purchased, right? And then when I do this now, you can see that somewhat rather, my sales price unit, which was float, gets converted to kind of like a double, and then it times with units, number of units purchased, and then it assigns to the total price as a double variable instead. So that's what an implicit conversion does. An explicit conversion is where we are explicitly going to convert it. So why would we do that, right? Why would somebody want to explicitly convert when we face with this kind of situation? Right, let me show you. Product price, right, equals to 500. But then we have product tax. But instead of this in a number variable, we get it in a string, right? And then we have a total product price, which the person has to pay, is equals to product price plus product tax. Simple. And I want to print what is my total product price. Simple, right? And when I run this, there's an error because a non-numeric argument is added to the binary operator. There's an error, right? Because we have a string here. It's 150, right? Now, this does not work. So how do we handle this? Right? That is the important part here, right? So instead of just immediately taking this product text as a value, you convert it using this as numeric option. So it will convert the string to a as numeric, and then it will become a numeric value, and you can see your output as 650. Right? That's what this explicit conversion does. Okay, let's look at round function. So what does round function do? So the round function, in this sense, let's assign a variable, actual variable, right? Actual, we call it actual, with the value, okay, 25879 divided by 658. That's actual. Then we display it, right? We do a cat actual value. You see, I'm using cat and actual and print interchangeably lah, so that you can also use cat when you want. You want to use you want to use cat, you want to use print, up to you. But in these cases, for this case, I have to use cat because I'm using two different variables, right? So now we have this actual cat value, right? Now I want to create a rounded value, but this time I want to use round instead. I want to use a round function, so I use rounded value is equals to round. I'm using the round function, and then I pass in 25879 divided by 658, right? And then same thing, but instead of actual value, I want to do the rounded value. I want to display the output. So here I'm going to set it as rounded value, and I call for the rounded value, right? When I print it out, when I run it, I mean, you can see the actual value is 39.32979, but the rounded value is 39, right? Okay. Okay, for this case, notice that the decimal value is more than 0.5, which is 0.813. So now I'm going to do another example and show you how the rounded value works, right? So let's assign an actual variable to 5879, but this time divided by 650, right? Just to change the numbers a bit to show you how it actually changes, right? And then I can just copy this because this is exactly the same and paste it here, right? And then I want to do same thing actually. I just have to change the value now. The rounded value is 650, right? And then I can just copy this as paste as well because it's exactly the same, right? Let's see how the value changes. You can see that because it's more than 0.5, it rounds up. When it's less than 0.5, it rounds down. This is quite simple, right? But that's how it works. Okay. Okay, the division of two integers will result in a double data type. Okay, this is very important. What happens when you divide two integers? It will result into a double data. This is also similar to the remainder data type value. Okay, so let's just try. Let's just try this. Okay, assign a variable x with 4 divided by 2. So x is equals to 4 divided by 2. Simple, right? Okay, let's make it a bit neater lah. 4 divided by 2. Right. Let's also do a remainder value with 4 percentage 2, right? Okay, then let's display the data type of variable x. So let's print x. I'm printing z. Print x. Print type of x, and print. Okay, and then we'll do print remainder and print type of as well, so that you understand. Let's see. I'm supposed to put an L here and an L here. Type of remainder. So you can see when I put, sorry, I left out the L. So when you want to do a remainder, or even here also I put an L. Sorry, because integers, you want to include an integer. Okay, so if you notice, right, when the division of two integers will result in a double data type. So if you look at this when I do a remainder, 4L divided by 2L, I get 2, right? And that's a double integer. But this is, in this case, this is not similar. This is not similar to the remainder data type value, because if you look at remainder here, okay, let's say I do 5. Just try to make it obvious. because there's really a remainder, because people say 0, there's no remainder, right? But if I use 5, right? 5, let me just be more clearer here, because 4L, 2L, 5L divided by, just to give you some context that there'll be a remainder, right? So when you 4L divided by 2L, you know that when the division will give you a double, right? But when you get the remainder of two integers, 5L, when you use the 2 percentage sign, when you get the remainder to 2L, it will not be the same. It will give you back an integer, because it's just a remainder. A remainder is usually in a whole sum, unless it's a fraction and all that, right? But you're looking at fraction and decimals. But here, remainder is usually a value, a specific value, right? It's one digit, so it's integer. So the system is able to consider that as a single value operator where there's no decimal places. Usually in remainders, you don't have decimal places, right? But unlike value itself, the system already knows when you have a value, when you divide A over B, it will automatically convert it to a double, because even though it gives you a full number, it will automatically give you a double. Let's try 5L divided by 2L. You can see that because it converts to a double, it gives it the ability to provide decimal values, right? That's why you have to be very careful that when you do a divide, it's different from doing, when you do a divide, it's different from doing a remainder, because the remainder is definitely a integer value. But when you divide, you can see in this case, it's no longer going to be a integer value. It has decimal probabilities. That's why the system is smart enough to convert it to a double before doing the conversion, right? The value itself. So yeah, so in this case, I'll revert this both back to 4 and 4, so that it's consistent with my understanding and my notes as well, right? Okay. Now, the remainder of even numbers divided by 2 will be 0, right? I think that's something that everybody should know, right? I'm just doing this because sometimes you need to identify, even numbers, and this is one way of how you can identify even number. So assign a variable with remainder 6 percentage 2, right? And then you want to display the variable remainder 6 percentage 2, and remainder is remainder, right? And the remainder is 0. Okay. Let's look at some insert some values to calculate. I think this is just to set you up for the next question that's going to come up, right? So we're going to insert a price with a quick read line input, read line, OMPT prompt, enter price, and then we want to do quantity, read line, prompt, enter quantity, perfect, right? Then we want to get the total cost is equals to price times quantity. Makes sense? And you want to print total cost. Simple, right? But what happens, right? Let me see. Let me put price of 10, quantity of 28. There's an error, because when you use readline, automatically your values are taken in as a string value. Readline always reads everything that you pass in as a string value, because it cannot assume that you're passing in a numeric value. So what you need to do is you need to explicitly convert it upon its insertion. So as you know, you put a s dot numeric, because you know the value is going to be a numeric value, right? And you do a s not numeric. Okay, and then you can print your total cost here. And then you can run this. Let me do it again. 10 for the price, 28 for the quantity, and you have 280 as the output. Okay, with that said, take 5 minutes to do this. Require user to input 2 values. First value for height in meters, second value for weight in kgs. Assign a variable height with the readline function, variable weight with the readline function again. Assign a variable BMI with the mathematical formula weight divided by height to the power of 2, and you display the variable BMI output. Try it out, and we will go through it. Okay, take some time, pause it, and try it out. Okay. Okay, let's handle this question. So the question is asking you for 2 variable inputs, height, so read line, right? But you know that you need to convert it. So what I'll do is there are 2 ways I can do it. I can do it at when I'm converting it, right? If you want to do that, you also can do that. But I'll tell you another way of how you can also do the same and make your code work even without doing it in the start, right? When it comes in, right? So you can do it meters, weight, read line, PROMPT, please, in quotes, please enter your weight in kilograms. And then I do a BMI, and this BMI is where I do my conversion, right? Height, weight, weight. Okay, weight divided by, okay, this one must be very careful when you do this kind of coding, right? So you need to ensure that it's because it's height times height at the bottom, so you have to do a power 2 and put them in bracket, right? And then you print BMI. Okay, let's put the height, let's put as 1.74, and the weight as 70, right? This is a normal person's weight and height, I think, right? And it's 23.12. I think this is a normal BMI, right? So, yep. So that's the quick practice, right? That's basically all I have. Until the next lesson. See ya.